Today we're going to be graphing hyperbolas. Our objectives are to be able to find the center, vertices, foci, asymptotes, transverse and conjugate axis length, and to be able to graph a hyperbola from standard form. What I have here are two pictures, one showing a hyperbola that's a left-right hyperbola, one that's an up-down hyperbola, and it can be very intimidating kind of looking at this, but it's very similar to an ellipse. We have a center, we have a left-right movement, we have an up-down movement, but instead of connecting those points as an ellipse, we're going to make a rectangle and draw in the extended diagonals, which gives us asymptotes. Then when we graph our hyperbola, either left-right, giving us vertices and having our branches go towards the asymptotes, or if it's up-down, our vertices happen to be the higher and the lower points, and again we draw our two branches going towards the asymptotes. And we'll have 4 examples later in the lesson. So if we have a standard form, it's very similar to a parabola. If you remember from parabolas, we had up-down parabolas, left-right parabolas, and it made a difference in the equation. It's very similar here. If we have a hyperbola that faces left and right, so it looks something like this, okay? That means that in our equation, and if you look, it almost looks identical to an ellipse, except with a hyperbola we have a subtraction sign. So how do we know which way it faces? We look at what is positive, or in standard form, what comes first. If the x value comes first, that means our vertices are left and right, and we have what we call a transverse axis that's left and right, which means our hyperbola is left-right. If our y value is the positive one, okay, that's going to tell me that my vertices go up and down, my transverse axis is up and down, which means my hyperbola goes up and down. And then we're going to go through some examples once we practice putting our equations into standard form. So what we have here are a whole bunch of different examples. Our goal is to make it look like the standard form that was on the previous page. And if you notice there, we have to have x's minus y's or y's minus x's. And it doesn't matter which one it is just is dictated by the equation. So we like to have everything on the left-hand side. Since my x's are already positive on the left-hand side, my y's are on the right. When I subtract the y's will be negative, so that's going to leave me with the x's first. So I'm going to have 2 times x minus 3 quantity squared minus 6 y plus 5 quantity squared equal to 24. Now if you notice, when I subtracted this term over, it just became a negative 6 y plus 5 quantity squared. The y minus 5 didn't become, the y plus 5 didn't become a y minus 5, and a lot of students make that mistake. They change the signs of everything instead of the whole term. But I have to remember that it has to equal 1. So my last step is to divide everything by 24. So if I divide everything by 24, I'm going to get an x minus 3 quantity squared over 12 minus y plus 5 quantity squared all over 4 equal to 1. And that's all you need to do. In my next one, the x's and y's are already on the same side. However, they're not in the correct order. We always put what's positive first and then what's negative second. So it's positive something minus something. So what I'm going to do, and again, this is all on the same side, so the signs don't change. I'm not adding 4x, adding the 4 part. I'm not subtracting the 2 part. Since they're on the same side, I'm just rearranging it. But now I have to divide everything by 4. Each term by 4, so I'm going to get y plus 2 quantity squared divided by 2 minus x plus 6 quantity squared all over 1. And we typically like to write the 1 just for standard form to help us out when graphing, equals 1. In my last example, it looks like it's in standard form. I have a positive minus another term, but it's not equal to 1. It's equal to 6. So what I need to do is divide both sides by 6. However, dividing by 6 with a fraction gets a little tricky. So instead of dividing by 6, I'm going to multiply by 1/6, which is equivalent. So if I multiply by 1/6, this is what I'm going to get. 2 is going to go into 6 3 times. So I have x plus 4 quantity squared all over 15 minus y minus 9 quantity squared over 36 equal to 1. And that's how you would get that into standard form. Let's go through 4 examples of graphing a hyperbola. I'll start off a little bit slower and I'll speed up as we go through once hopefully you feel a little bit more comfortable with the process. So just like an ellipse, what I want to do is solve for the center. And I also want to take note of what term is positive. Since it's the x, I know it's going to be a left-right hyperbola. And sometimes I like to draw a little picture just to remind myself that when I'm graphing it, where the vertices are going to be and which way I should actually draw my branches. So this is just like anything else we've done. I'm going to have a negative 3, comma 1 for my center. Negative 3, comma 1. And now I'm going to do my left, right, and up, down movements. Okay, so I know my A is 2, and for me the B is 5. A is for my classes is always the left, right motion. Moving to the right, and then moving to the left. B is the up and down, our movement 1, 2, 3, 4, 5, and down 5. Okay. Now if you notice, in our last lesson, I would have connected these to make an ellipse. But what we're going to do now is make a little rectangle. And again, we're going to have a lot of things dashed. And the reason they're dashed is because they're not actually part of my hyperbola. They just help me draw it. So this is to show me that it's there, but it's really not there as far as my graph is concerned. Okay. After I do that, I also want to notice that because it's a left-right hyperbola, this point on the left, this point on the right, those are my vertices. So that's going to be negative 1, 1, and negative, let's see, negative 5, 1. Okay, now, I'm going to get to the foci in a second, but I'm just going to show you how to actually draw the rest of it. The next thing I want to do is to draw in my extended diagonals. Those are my asymptotes for my problem. So what I'm going to do is go each direction. Again, these are dashed because they're just here as guidelines to help me graph. They're not actually part of the parabola, or the hyperbola itself. Alright. Now, I can actually graph my hyperbola right now. I actually have enough information to actually just graph my branches. And what a lot of students do is they do all this work and then they actually forget to draw this part in. This is the actual hyperbola, so this is the part you actually want to see. Make that look a little bit darker so you can see. And it should have arrows, and it should goes towards your asymptotes. Okay. Just try to darken that in for you. Okay. Now, just like we had with a parabola, we had this focal point that was inside a parabola. Well, same thing here. In each branch of a hyperbola, we're going to have this little x, our two focal points. So how do we find that? Well, it's very similar to what we did with an ellipse. If you remember from an ellipse, I had a squared minus b squared equal to c squared. But that's because an ellipse had a plus sign here, so we subtracted, took the actual absolute value. Well, in a hyperbola, I have a minus sign here, so that helps me remember that I'm actually going to do a squared plus b squared equals c squared, which you should hopefully know as the Pythagorean theorem. Even though we're not dealing with triangles here, that's the same formula we're going to be dealing with. So a squared plus b squared equals c squared. So my a squared is 4, my b squared is 25, so my c squared is going to equal 29. But I care about what c is. C is the square root of 29. So that means I'm going to move right root 29 and left root 29 from my center. So if you're going to actually do that, okay, the square root of 29 is approximately 5 point something, right? Because it's more than 25 but less than 36. So if I was actually going to graph this, I would go from my center 1, 2, 3, 4, 5 and a little bit more. 1, 2, 3, 4, 5 and a little bit more. Okay, just like we did before. Sometimes these will actually be off your graph, so I'm not going to worry about you graphing them too much, but I do want to show you for our video what they look like. So how would I actually write that? Well, just like we did with our ellipse, because this is a left-right motion and movement, I'm going to be changing my x value. So my x was at negative 3 for the center, but I'm going to be moving to the right, plus, and to the left, negative, root 29. And I stayed at the value 1 for my y. Now asymptotes. Okay, asymptotes are these two lines. So how do we write the equation of a line? Well, we had 3 different ways to do it back in our chapters with lines. We could write it in standard form, we could write it in slope-intercept form, which you guys are most commonly use. However, point-slope form is the best. if I notice these two asymptotes go through the same point, the center, and I know the center, remember, is at the point -3, 1. And what is the slope of these lines? Well, if I pick any 2 points, I know it goes through here and through the corner. I went up 5 over 2, which is my B and my A. So I know my slope is up 5 over 2. However, this one is a positive slope. This asymptote is a negative slope, so I have a plus or a minus. And I'm going to use those two pieces of information to write my equation of my asymptote. Well, if you remember point slope form, we do y minus the y equal to the slope. I have a positive and a negative, 5/2, and then the x minus the x. Okay, so where can I find these pieces of information in my original equation? Well, here's y minus 1. I see a y minus 1. X plus 3. I see an x plus 3. And where do I get my slope from? Well, it's rise over run. Well, how much up and down did I go? That's the b value. How much left and right? That's the a value. And it's plus or minus because I have two asymptotes, one positive, one negative. Alright, so the last two pieces are the transverse axis width, which is kind of like our major axis, which connected the two vertices, which is right here. So how far left and right did I go? Well, I went 2 right and 2 left, so that's going to be a total of 4. Conjugate axis is the other width, which in terms of our ellipse would have been our co-vertices. But the big thing with an ellipse, we had major and minor. Major was bigger, minor was smaller. That's not the case here. It doesn't matter which one's bigger or smaller. Transverse axis connects the vertices. The conjugate axis is the one that connects the other 2 points for the rectangle. So I went up 5 and down 5, so that's a value of 10. We're going to go through this process again. I notice that the y is first, or the positive, so I know this is an up-down hyperbola. Going through it, now this is where most students mess up. Remember, when you do the center, it's always x comma y, so look at the x part first, not what comes first in our equation. So it's going to be 2 comma negative 2. So 2 negative 2. Okay. Now I'm going to go through and draw the box. I know I'm going to go, this is under the y, up and down 4. Okay. And underneath the x is a 9, so I'm going to go left and right 3. And again, from there, I'm going to just draw in my rectangle and then draw in my 2 asymptotes, which are the diagonals of this rectangle. Okay. And that's the first process that you need to do for every hyperbola. Technically, after you do this, and if you know what direction it faces, you're done, but I am going to always ask you guys all these extra pieces of information just to make sure you know a little bit more about what's happening. Okay, so which one of the vertices? Well, this is an up-down hyperbola, so I know the point that I used up here and the point down here I used for the rectangle are my 2 vertices. So those 2 ordered pairs are going to be a 2 comma 2 and a 2 comma negative 5. Oh, I'm sorry, negative 6. Okay. The 2 focal points, and we can kind of fill this in right away, is a squared plus b squared equals c squared. So my a squared is 9 plus my b squared is 16 is equal to c squared. 25 is equal to c squared, so c is equal to 5, which means if I go from the center, and because this is an up-down hyperbola, if I go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, those would be my 2 foci. So what are those ordered pairs? Well, one is going to be at 2, 3, and the other one is at 2, negative 7. Okay. I'm just going to draw in the actual hyperbola so we can see it. Okay. The asymptotes. Okay. I can actually just look up here. I know it's going to be y plus 2 equal to, and I have to find my plus or minus my slope, and it's going to be the x part, x minus 2. Again, the reason this happens is because I'm going to be using the center as my point. Well, what's my rise and run? Well, I went up and down 4, left and right 3. So I went up 4, my rise. My run was 3, so it's plus or minus 4/3. Transverse axis width, I went up 4 and down 4, so that's 8. Conjugate, I went right 3 and left 3, so that's 6. Okay, the next one, again, is a left-right hyperbola. My center happens to be 5, 1. And then again, go to draw the box. I'm going to go left and right 3. And then up and down 2. Okay, so draw in your rectangle. Draw in your 2 diagonals. And then decide where your vertices are. So if I go through here, because it's left-right, I know my vertices would be these 2 points right here. And I always like to make them, even though I have different colors here, but if I was doing this with pencil, I would just darken those in. So now I can write those ordered pairs. 2, 1 and 8, 1. I'm going to take the time right now to actually graph my hyperbola so I don't forget later. The 2 focal points I get from taking my a squared plus my b squared equal to c squared. So 13 equals my c squared. And then c is equal to the square root of 13, which does not reduce. Again, I'm going to be adding this to my center. The square root of 13 is approximately, well, it's between 3 and 4, right? It's between 3 and 4, so it's 3 point something, because greater than 9 but less than 16. So I'm going to go 1, 2, 3 and a little bit, 1, 2, 3 and a little bit. Okay, that's where the 2 focal points would be. So how would I write that exactly? Well, since I'm going left and right, that's changing my x value. So I'm going to do 5 plus or minus the square root of 13, comma, 1. The asymptotes, I'm just going to look at my equation. I have y minus 1 equal to plus or minus. I went up and down 2, left and right 3, so rise and run. And then I'm going to write x minus 5. The transverse axis would be 6. So it went left 3 and right 3. The conjugate axis is 4, up 2, down 2. And our last one. Okay, I can tell this is going to be an up-down hyperbola. My center, I want to be careful, again do the x part first, is negative 6, comma, 0. Okay. I know I'm going to go, this is under the y, so up and down 5. And then left and right 7. Now this one happens to fall a little bit off the graph, which is okay. So let's see. Okay. 1, 2, 3, 4, 5, 6, 7. Just so we can see a little bit. Now it's sometimes really hard to play around with numbers and give you guys some different examples if it's always, between 10 by 10. And you could change the scale. But for me, just because this is our last example and I just want to go through another one, having it off the graph a little bit isn't going to kill us. Okay, then I'm going to draw in the diagonals. Okay. I know this is an up-down hyperbola, so I know these 2 points are my vertices, okay, which happens to be negative 6, 5, and negative 6, negative 5. Again, to find the foci, I'm going to take a squared and b squared, again the order doesn't matter, to equal my c squared. Okay, so this is going to be 74. So c is equal to the square root of 74. If I try to break that down, that's 2 times 37, which both of those are prime, so I don't have to worry about breaking it down any further. So I can just leave it as a square root of 74. Okay, I can tell that I know, because it's an up-down hyperbola, that I'm going to move up and down, which is going to affect the y value of my center. So if I start at negative 6 and go up root 74, or down root 74 from 0, that's where my 2 focal points would be. Again, if I want to know what this is, I know it's going to be approximately 8 point something, because it's going to be between 8 and 9. 8 squared is 64, 9 squared is 81, and 74 is between that. So if I go up 8 and a little bit, and go down 8 and a little bit, those would be my 2 focal points. Those always fall inside your hyperbolas. And then I could go through and finish up with the asymptotes. Again, you're going to do the y part first. It's just a y because I don't have to subtract anything. My slope is I went up and down 5, left and right 7, and then x plus 6. Big mistake students make with asymptotes is they put squareds in here because they're so used to everything we're doing in the conic section being squared. But remember, asymptotes is the equation of a line. The last thing, my transverse axis, I went up and down 5, which is a total of 10. I went left and right 7, which is a total of 14. I hope you feel a little bit better about being able to find the center, vertices, foci, asymptotes, transverse, and conjugate axis length, and to be able to graph a hyperbola from standard form.